Mr. Obadela, are you able to hear me?
Good morning, Mr. Chilkuri. You are loud and clear.
Yeah, okay. So we're waiting for the others to join up, right?
Correct. And
Okay.
then once we get the note from the our chair, then we can start the session.
Okay. You also a speaker, no?
Yes, I'm a speaker as well as I will be also chairing the session also.
You are chairing the session. Okay, fine. So now you have all these things with you, the video recordings with you, right? You can play.
Actually, yes. Actually, I'll not be playing. On the backup, we have a technical team. They will be playing. Actually, I don't have to. You also don't have to worry about this. Our backup team will take manage this. This part.
Yeah. And then I need to be available for the question and answer session, right?
Correct.
And,
yes,
okay, fine.
We'll call you. We'll call you.
Okay. Yeah. Anyway, I'm here.
What we have planned that each presentation after completing each presentation will be asking for the question and answer session, not at the end all together.
Fine. So about 5 minutes, right? 5 minutes.
5 minutes. Yeah.
Fine. Because yesterday I've seen the other presentations of other people also. I mean, it had about 5 minutes of question answer session from other division. That's what I said. Yeah, so good.
Yeah, actually, it may not last too long, because if we don't have a question, maybe 1 or 2 questions, then we have to wait.
Fine.
Thank you very much.
Okay. I'm standby. Good morning, Mr. Somendranath.
Yes, good morning.
How are you doing?
Fine.
Okay. You're also presenting a paper?
Yes.
Okay. Are you one of the person chairing?
Yes, second chair.
Okay, second chair. Okay. I'm one of the speakers. Yeah.
Good morning, sir. This is Sarolapati from IIT Madras. I'm the coordinating for this session. So can we wait for the 3 more participants not to join? So can we wait for that, or else we can start? Bashish?
Yeah, I'm okay. We can start the session. I think the first presentation is from my side, and our second presenter is
Chilkuri Makesh.
Yes,
yeah, I'm here.
He's also here. Actually, we can start, and then if they come join within 10-15 minutes, I think they can join, and then they can be in the question and answer session. So I think better if we start.
Yes, sir. Thank you, sir. The session is hand over to you.
Yeah.
Thank you.
Very good morning, good afternoon, and good evening to all our audience from all over the world. And I welcome you all to Ocean 2022 conference, Chennai. And I'm Mohammad Obaidullah Ibn Bashir. And with me, Mr. Sumendranath Uzgankar will be serving as a session chair and moderator today. I'm presently working in Department of Shipping Bangladesh on maritime policy and strategy related matters. Before we begin, I have a couple of important notices from Oceans to share. All videos presented during this session will be limited to maximum of 13 minutes. All videos will be available on demand in the video gallery on the virtual conference platform, where you will be able to watch this content at your convenience. If you have missed anything during the presentation, this will be a great way you can catch up. In this session, there will be 6 recorded presentations. Presenting authors are Dr. Prashan Goswami from National Institute of Ocean Technology, Mr. Avijit Mohati from Indian Maritime University, Mr. Surya T. Anna, University College of Engineering, Mr. Somendranath Uzgankar, National Institute of Technology, Goa, Mr. Chilkuri Mahashar, Anglo-Eastern Maritime Academy, and myself, Obaidullah Ibn Bashir from Department of Shipping, Bangladesh. Our presenters will be available for live question answer session after completion of each his or her presentation. And we encourage you to use the chat box on your screen to submit any question that you have. So now I'll request my co-chair, Mr. Somendranath Uzgankar, to start the session and the presentation. Thank you.
Thank you, Mr. Abdullah Bashir. Good morning, everyone. I am Somendranath Uzgankar from National Institute of Technology, Goa. Now we have this session's first paper with title Application of Internet of Things to Calibrate with IMO 250 Decarbonization Charters and Phase Out Greenhouse Gases from Shipping Industry of Bangladesh by Mr. Abdullah Bashir from Department of Shipping, Bangladesh. So I request the team to play the video of the first paper.
French President Emmanuel Macron commented, "By polluting the oceans, not mitigating CO2 emissions, and destroying our biodiversity, we are killing our planet. Let us face it, there is no planet B. It is our utmost duty to protect our oceans and our earth for our next generation." Good morning, good afternoon, good evening, ladies and gentlemen. My sincere gratitude to you for watching this presentation from different parts of the world and the Ocean 22 Conference Chair for giving me the privilege to deliver the paper in this prestigious platform. I am Mohammad Obaidullah Ibn Bashir from Department of Shipping, Bangladesh, involved in maritime policy and strategies, and shall be presenting my paper on the application of Internet of Things (IoT) to calibrate with the IMO 2050 decarbonization charters and the phase out of greenhouse gases from shipping industry of Bangladesh. International Maritime Organization (IMO) in April 2018 laid out the strategies for shipping industry to reduce its greenhouse gases emission 50% by 2050 from the 2008 level and the CO2 emission per transport work by at least 40%. Since the challenge is global, a coordinated participation of all the stakeholders is required to materialize the IMO Decarbonization Charter 2050. Disruptive technologies such as Internet of Things, IoT, blockchain, machine learning, etc. and the use of alternative fuels are likely to speed up the process. Surveillance plays a crucial role in achieving the sustainability of IMO Decarbonization Charter's objective. IoT, considered as a breakthrough technology, has the potential to help the stakeholders and the government agencies to build up the advanced surveillance capabilities that can be connect anything with the anything at any time from anywhere without any human intervention. Bangladesh Maritime Safety Administration needs to develop advanced surveillance capabilities for the compliance to IMO Decarbonization Charter. IMO 2050 Decarbonization Charter aims to phase out the emission of greenhouse gases. Ships' Internet of Things, if customized and supported by augmented intelligence, can detect the greenhouse gas and the CO2 emission compliance. For this study, both the qualitative and quantitative studies were used. Secondly, data collected from existing books, reviews, researches, journals, website, and the magazines and blogs on the ontological and narratives of ships' Internet of Things, artificial intelligence, augmented intelligence, big data, IMO Decarbonization Charter 2050, use of alternative fuel, etc. IMO laid out the emission standards for this member state, requiring their shipping industries to cut greenhouse gases by at least 50% from that of 2008 by 2050. Despite opposition from the numerous countries, IMO had pushed for tougher greenhouse gas goals, and the draft agreement was reached to cut out the emission by 50% by 2050 and 100% by 2100. Ironically, according to the International Council on Clean Transportation ICCT and the newly adopted IMO Decarbonization Charter legitimates shipping industries to consume the world's carbon budget between 3.8% to 5.8%. The medium-term measures to be implemented between 2023 and 2030 will likely to include low carbon and zero carbon alternative fuels. Stakeholders across the globe welcoming it as a groundbreaking agreement are confident that implementation of this charter will decarbonize the entire sector completely, keeping it consistent with the 1.5-degree climate change goal. The Internet of Things, hailed as the next frontier of information technology, can empower the shipping industry with the information superiority by giving access to the information by shared awareness, self-synchronization, and mobilize operational command. By definition, IoT refers to a network of items, each embedded with sensors which are connected to the internet to collect, process, and transmit data. They allow the things to hear, see, think, or act by communicating and coordinating with others to make decisions that can be as critical for the safety and pollution prevention. Bowney rightly mentioned that IoT is a revolution, while IIoT is an evaluation. So now how this IoT and augmented intelligence will work? IoT can help enforce the IMO Decarbonization Charter. An IoT gateway connects to the cloud to the ship's controllers, sensors, and intelligent equipment. All data traveling to and from the cloud goes through the gateway, which can be hardware or software. A smart gateway or control tier is another name of the IoT gateway. A gateway that allows to process the data locally before transferring it to the cloud. By aggregating, summarizing, and strategically analyzing the data at the edge, less data needs to be sent to the cloud, reducing the reaction time and network transmission cost. The IoT devices connect to the IoT gateway via Bluetooth, Zigbee, Z-Wave, LTE, LTE-M, Wi-Fi, and then to the public cloud via Ethernet LAN or the fiber optics one. The IoT gateway recognizes this protocol and may transfer them to the other protocols required by the data system. This figure depicts the three stages of makeup the network. The system provides advanced surveillance capabilities, allowing operators to monitor CO2 and other greenhouse emissions in real time. Sensors and smart device is used to identify the varied amounts of carbon dioxide or greenhouse gas emissions from a ship in a real time while traveling at the different speed between the ports. Sensor at present used to control fuel consumption rate, fuel mode, engine temperature, pressure monitoring, and the performance evaluation. All these sensors can be connected to the ship's IoT to expose ship's performance, location, speed, fuel consumption, CO2 emissions, etc. During the voyage, this sensor will start collecting data in real time and transmit them to the IoT cloud. Next, the cloud uses big data analytics to immediately recognize the excessive carbon or the greenhouse emissions and reroute the equipment or the engine to alternate fuel sources, keeping the carbon output under control. Now, whenever the sensors or local devices detect excessive CO2 or greenhouse emission, they will send the data to the ship's cloud. Recognizing the violation, the cloud automatically redirects the machine or utilize alternate fuels to adjust speed. To sum up, utilizing IoT protocol, all data about a ship can be sent to a remote control center on land, where data engineers may continuously monitor the carbon emission rate of the ship traveling in the sea and advise them to either change their speed or utilize alternate fuels. Ships' Internet of Things become an augmented intelligence by nature, enabling a human-centered partnership model of the people and artificial intelligence to increase the cognitive performance. Another thing is that because the IoT data trails can be used to enforce advanced surveillance system, they can also be used for predictive surveillance. The technology will alert the vessel master and the operators before they produce excessive CO2 or greenhouse gases owing to their maybe speed, fuel type, or maybe excessive loading. It will indicate when to use alternate fuel, change speed, or maintain a specific speed based on the sea waves and the currents to reduce the carbon or the greenhouse gas emission. So what are the IoT requirements? Security is required to monitor and building the advanced surveillance capabilities. The government and stakeholders need to support ships' Internet of Things and evaluation of IoT with more robust security features. This includes secure and resilient system architectures, authentications and encryption, specialized chipset, threat detection, and the management processes. Ships' Internet of Things must integrate without issues. IoT solution linking to all operating vessels at a particular time in a country need to support a range of autonomy requirements. The system must be supported by a backup system and supportive of fault tolerance. Since it is measuring the amount of carbon dioxide and greenhouse gas emissions from all the water vessels and ships in operation in the country, a little faulty reading may create a big difference in the accumulated results. Hence, ships' Internet of Things solutions must support precise and accurate operation to maintain efficiency. Thousands of ships and water vessels shall be monitored continuously, linking them to a single platform, monitoring and the reading of the carbon dioxide and greenhouse emission of every second matters. Hence, ships' IoT solution must be built to support low latency. So what are the IoT frameworks and standards that we need? Several international frameworks and standards are running and securing ships' IoT systems. Different vendors have different standards and guidelines. Too many standards and frameworks increase the possibility to fail for the wrong standards. So organizations like Industrial Internet Consortium, IIC, and IEEE Internet of Things have decided to publish them and same could be followed. So now we come to recommendation. The IMO Decarbonization Charter 2050 with the help of disruptive technologies will refresh the shipping industry. The policymaker should deliver promptly on applying the Internet of Things, big data, augmented intelligence, machine learning and other disruptive technology. They also need to upskill the existing workforce, setting up new policies and strategic frameworks, and sanctioning the necessary budget for implementing IMO Decarbonization Charter 2000. So here comes the challenges that we face for this study. Data collection was delayed due to the communication gap and COVID-19 lockdown. Respondents were little hesitant to provide the sensitive information, and there was a public office bureaucracy as well. And the limitation of our study was in-depth interview was not conducted, rather it was contextual, unavailability of resources and the small sample size. So here are our major references that we used during this study and this paper. So now we can proceed to the question answer session. Thank you very much for your patient hearance.
So thank you, Mr. Bashir. So if you have missed any portion of this presentation, all the video presented during this track will be available on demand on virtual conference platform, where you will be able to watch content at your leisure. Now I request audience to kindly put the questions in the question answer box.
I can see here that there is no question from the audience. So here we have some our presenters. So anyone have any questions? I am here to answer. And basically, just I give you outline. This study was done in view of IMO decarbonization. Though there are a lot of experiments and things are going on decarbonization issue, but how this will be monitored, there was little emphasis at this moment. So when as the administration we are working, we also thought that how this will be monitored. So on this basis, this study has been done, and mostly this data is from the literature review and a few interviews from the technical management of different shipping companies. So that gives us a framework that how once these rules will be implemented, then how we'll be monitoring this compliance to decarbonization rules. So again, I'm open for the question and answer session, but in case you don't have, then we can proceed to the next presentation.
Mr. Bashir, I had one question.
Right.
So, which are the parameters that the IoT system will monitor or?
Right. So if we say broadly for understanding, it is definitely the greenhouse gases, because that is and the carbon emission, because that are the things actually the regulation is coming in place, and by 2050 we have to reduce it. But it is not only the carbon emission, because this is related with the ship speed, ship's draft, loading condition, because the more it is loaded or the higher speed it goes, the carbon emission will increase. So basically these are the major parameters. So as I told in my presentation, there is also predictive system that once we get more loaded, maybe due to loading or maybe due to the weather condition, or the speed is high, then automatically it will give us the signal that we should now either reduce the speed or reduce the load, or we can actually change over to the alternate fuel, so that greenhouse gas emission will be reduced. So these are the major parameters, but there are other, I can say there are a lot of other parameters will be taken. But again, it has to be kept limited, because if there is too many data transmission, then it will be difficult to monitor, because actually we are not going to monitor only one ship. Suppose we are planning for this our coastal area where nearly 3,000 to 4,000 ships flying. So 3,000, 4,000 ships is a lot many ships and with a lot of data. So we have to keep the system simple and also effective and reliable. So we'll keep just only bare minimum data for this monitoring system. Thank you.
Thank you, Mr. Bashir.
Okay.
I don't
Mr.
see any
one minute. Mr. Bashir. So,
Yeah.
I mean, it was a very good presentation. So very, very enlightening and all. So I was thinking it's not really a question. So maybe can we extend this logic, Internet of Things, to autonomous shipping as well? Not directly related to your presentation, but maybe it can be over a period of time. We can extend it to autonomous shipping also.
Yes, you are absolutely correct. Actually, autonomous ship, it is more easy, because your autonomous ships, as you are aware, the full control will be from the shore-based control system. So where all the data will be going. So actually, it is more easier for the autonomous ships rather than now conventional ships, because for conventional ships we have to put many sensors and also communication device. But autonomous ships will come along with all these things, So it is actually, I would say that autonomous ship is already ready-made system that will come with this monitoring system. Thank you. I think I have answered your question.
Okay, thank you, sir. Thank you.
Thank
you. Fine.
So moving on to the next paper, we have this session's second paper with title The Thawing Arctic, a Boon for Shipping or a Bane for Humanity by Mr. Chilukuri Maheshwar from Anglo Eastern Maritime Academy.
Good morning. My name is Maheshwar, and I'm here with you to share my presentation on the problems the Arctic is facing because of the newly opened shipping routes. So I'm sharing my presentation with you. The thawing Arctic, a boon for shipping or a bane for shipping humanity. Okay, CM Maheshwar, Department of Marine Engineering. I'm a faculty member in Anglo Eastern Maritime Academy in Karjat in Mumbai. This is a little brief about myself. So I'm a marine engineer, 1980 pass out DMET, MBA, MBA, MPhil in management, full-time faculty at Anglo-Eastern Maritime College, Karjat, Mumbai. Complete 2 decades in maritime training, including 1 decade in AMA. Published 2 books, Container Refrigeration in 2008 through Witherbees UK, first public book to be ever published by an Indian author in Witherbees on the subject, and is listed as a reference course material for US Coast Guard's MARAD's Marine Engineers licenses on marine refrigeration air conditioning, refrigeration person safety in 2021 through Bhandarkar Publications. And my expertise includes marine engineering, naval architecture, refrigeration, containerization, cold chain, post-harvest management, and sustainable solutions. So these are the pictures which I'm proud of, in which I'm presenting my book to Dr. Abdul Kalam. So I'm really proud of this moment. So I normally keep it around me. Now, this is the roadmap of my presentation. First, we'll talk about the Arctic, the new shipping route, the genesis and advantages and all. Then the problem caused by this new shipping route. The new shipping lanes will accelerate global warming through the black carbon. The third is, what are the solutions, possible solutions, what are practical aspects? The climate warming black carbon in the Arctic can be hard by the shipping industry. The fourth one will be the regulator's contribution. There's IMO, the fuel dilemma by the ship owners and by the refiners. And we'll have a brief look at the various oil spills in the Arctic. What are the effects? And finally, what are the positive steps that has been taken by some people, a man, towards mitigating this hardship, this problem of the Arctic global warming because of new shipping route. And I close it by the references. So this Arctic route, a new shortcut which has been developed, say about almost maybe 30, 40 years back. So this is the northwestern route, and this is the northeastern route, let's say, original route, and this is known as the western route. So northwestern route, the link between Canada and Japan, eastern Canada and Japan. Northeastern route is the link between China and Europe along the north coast. And what are the advantages of this new route which has been discovered? The saving in distance of 40%, 1/3 shorter than the shipping via the Suez Canal, less fuel is expended. And when less fuel is expended, so less global warming, less carbon impact, and so on and so forth. And the environmental cost saving in CO2 emission per voyage is US $84,000 for a tanker and $130,000 for a container ship. There are some assumptions, assuming 3.0 tons of CO2 per 1 ton of marine fuel oil, or heavy oil as they call it, and US 25 per ton of carbon dioxide released in the atmosphere. So, okay, it is good. It's good for the environment. We are going to save a lot of money. But again, that's not the end of it. Now, when did it start? It's sometime in about 1945 or so, Sir John Franklin of UK tried to navigate these waters. 2 ships got in strike in the ice in the Arctic region, and all 129 crew members died in the accident. And for a long time, there was a lull. And again, 2013, ship called Nordic Orion sailed across the passage, helped by the Canadian Coast Guard icebreaker. 2014, cargo ship Nunavik made an unescorted voyage, carrying nickel from Quebec to China in 26 days instead of 41 days. 2015, about 16 vessels made the journey. 2016, 18 ships had made the journey. And 2017, 32 ships had crossed the passage. Now, what is the problem with this new shipping route? Well, one is the noise, which interferes with the marine habitat, because when the ships are moving, there is a vibration, some noise is created. That noise travels underwater and then affects the marine habitat, marine life. And it interferes with the communication between marine creatures of the same species. Their mating habits, they are in a shock. They are confused otherwise. Vibration, causing faster melting of sea ice. Some vibration is always there. That is affecting the thing. And then slowly, it starts melting. The smaller, it generates cracks in the ice. And then the melting is faster. Incomplete combustion of ship's fuel causes black carbon particle deposition. And when it deposits in the ice. And this contributes to the melting of Arctic ice. Black carbon also contributes to global warming, after carbon dioxide is the biggest contributor towards the global warming. About 42 million tons of carbon dioxide and 4 million tons of black carbon are produced annually by the shipping industry today. 1 ton of black carbon emitted in the Arctic region produces a warming equivalent to 4,000 to 7,000 tons of carbon dioxide over a period of time of 20 years. So this is a ghastly figure that we should take note of. Now it's a vicious cycle. Sunlight gets absorbed by the atmospheric black carbon and the air around it gets heated. Particles of black carbon can also fall in the ground. Surface reflectivity, albedo, gets reduced while continuing to absorb heat, thereby accelerating melting. More sunlight gets reflected by ice and snow than the ocean. More melting ice absorbs more heat, causing more, creating more water, which can absorb more heat. The cumulative effect is a positive feedback loop that speeds up Arctic warming. There's the black carbon, more information. Carbon dioxide remains in the atmosphere for about 100 years. Black carbon particles last not more than 3 weeks in the atmosphere, after which they fall to the atmosphere and get deposited in the ground. And when they come onto the ground, okay, they're going to create a lot of havoc. So black carbon gets left out in the atmosphere by planes that fly over the Arctic at a high level in the atmosphere. But the air is more stable here. This stratospheric black carbon can last for months or even years. It's going to remain in the stratosphere area. A continuous source of black carbon caused by the cumulative effect of ground emissions, particularly ships, maybe road transport, okay, ashore, gets transported from populated places like Europe and Arctic. Because of the rotation of the Earth, this thing gets carried forward and gets accumulated near the polar regions. These emissions only increase as more and more shipping routes open up. Arctic melt. Shipping contributes to only 2% of the Arctic black carbon emissions. However, the great impact is there. It has a much greater impact. Black carbon particles emitted from the ships in turn remain for as long as 2 weeks in the lower levels of the atmosphere, absorbing much heat all along, settling down, comes into contact with the landmass. Warming impact with black carbon increases exponentially about 7 to 10 times, acting as an accelerator to the Arctic melt. So the regulator, that is International Maritime Organization, IMO, has mandated 3 solutions. One is shift to low sulfur fuel. Now we are using 3.5% sulfur, and from 2020 onwards, we are supposed to be shifted to 0.5% sulfur. However, it's more expensive. Let's see what it is. Then use of scrubbers. The scrubbers are already in use ashore. So we are putting the scrubbers on the ships also, but it doesn't take out the carbon totally. It's effective, but not 100% effective. And some additional costs are involved. Use LNG as a fuel. Unfortunately, the shipping industry is not yet ready for this shift to LNG fuel. Marine diesel engines, the marine bunkering procedures, the storage facilities on board. We are not yet set with the protocols. So that is a little distant away. Fuel dilemma. The shifting to sulfur fuel is not so easy. Low sulfur fuel is not easy. It can't happen overnight. Manufacturers have to be ready technologically and commercially also. They have to see that their profit margins are not eroded. At least they should withstand the changes in the demand. Only big players can take the hit. Customers or shipping industry need to upgrade their machinery. The ships have to upgrade the machinery so that they can burn the low sulfur fuel. There's a cost to it. Who will absorb the cost? Ultimately, that cost has to get passed on to the end consumer. That is you and me. Now, Arctic had lots of oil spills in the last few years. Exxon Valdez is the, you can say, the major one which is there. And Serendang, Ayo, Navion Britannica, 2007. Other oil spills also there in Norway. Let's see what they are. Now, this Exxon Valdez has occurred in 1989. That's about almost, let's say, 33 years. However, even now also the effects are being, and then some species have been totally wiped out because of that. Some species, they still survive. They have recovered. But some species, they are not going to recover at all. So that's the long-term effects that these oil spills are going to have in the ocean. Not only in Arctic, everywhere in the world. And this is the list of the oil spills which have taken place in the Arctic region in the last maybe 20 years, 30 years. So, to name a few, Ecofisk oil field, MB server, Full City, Golafos, all these are the names of the ships. Some are the tankers, some are the container ships. So they have actually given out oil, spilled oil into the space. What are the effects of these oil spills? Loss of marine life, expensive cleanup, hazardous cleanup operation, loss of livelihood for the local population, prolonged environmental effects, just like we saw just now for Exxon Valdez, expensive civil and criminal litigation. These are various problems associated with oil spills. Finally, there's some hope is there. Everything is not hopeless. A ray of hope, a modest beginning has been done. A recent voluntary self-imposed ban on the use and carriage of heavy fuel oil in the Arctic region has been approved by the Association of Arctic Expedition Cruise Operators, AECO. It is nevertheless, it's a good thing to happen, and small step for man, but a giant leap for mankind. If everybody can follow them, there's nothing like it. These are references from which I picked up my information. Thank you.
Thank you, Mr. Chilikuri Maheshwar. If there are any questions from the audience, please put your questions in Q&A box.
I think we have no question in the chat box. So I have a small question to Mr. Chilkuri.
Yes,
Mr. Chilkuri, it is excellent presentation and actually nice, a very lot of information is there, and it is very understandable and very easy way. We audience got all the information. So there are positive sides and negative sides of this. We having a route through Arctic. So my IMO also involved with the new legislation on Arctic, how the Arctic vessel will be designed and what type of fuels they will consume and all this thing. So can you highlight on the this thing that what are the IMO what the IMO is planning to do about the safety of the vessel that will ply through the Arctic?
So see, now IMO has made a lot of rules about the ships, how strong they should be, and that means they want to encourage shipping through the Arctic route, which I'm not in favor of that. As an individual, as an environmentalist or whatever it is, I'm not, because the moment you allow more and more ships to go through that place, I mean, it is going to create havoc to the atmosphere. So I don't really agree with what IMO is really doing it. In fact, they should be discouraging the use of Arctic if you want to retain the sanctity of the planet. I mean, it's my personal opinion that it is there. Okay. Otherwise, they are having their rules in order to strengthen the ship. They want to encourage shipping through the route, through the Arctic regions.
Thank you, Mr. Chilkuri.
Yes,
well understood. Thank you.
Yes.
So I think if we don't have any more questions, then we can proceed to the next presentation. I cannot see, still no question has popped up in the chat box. So we are going to the next presentation, and we'll be displaying the recorded presentation from Mr. Sumendranath Uzgankar, National Institute of Technology, Goa, on WQNet, a deep neural network model for water quality prediction. Enjoy the presentation.
Hello, welcome all to this presentation. My name is Shubham Palkar, and I'm here to present a research work named WQNet, a deep neural network model for water quality prediction. This project is done by me and my team member Somendranath Uzgankar under the guidance of Ms. Sadaf Ansari. I would like to thank IEEE and all the patrons and sponsors of this conference for giving us the opportunity to present our work. So, the outline of this presentation is, we will first start with an introduction, then we will look into the current water quality measurement techniques that are being employed, the objective of our research work, then we will have a glance at the outcomes and impacts of our work. Next, we will see the methodology, and proposed model, and then we will end up with the results, conclusions, and future scope of our research. As we know, ocean water quality is fundamentally essential for all the plants and animals that depend on the ocean, as water pollution can affect the ecological functioning of the marine organism. The present study of water quality prediction is based on the analysis of 1,744 samples of water collected from different rivers from various locations across India. The water quality parameters were analyzed using deep learning techniques to predict water quality. We can express the overall water quality in terms of WQI, that is Water Quality Index. Basically, WQI is a single number which reflects the combined effect of many water quality parameters, and it is used to measure water quality. And WQC, that is Water Quality Class, is a way to represent a class of water based on WQI. Here below is the table which shows the different classes of water quality based on the ranges of WQI. As can be seen, the ranges from 0 to 25 is classified as an excellent water, 26 to 50 is classified as good, 51 to 75 is classified as poor, 76 to 100 is classified as very poor, and WQI values which are above 100 is classified as unsuitable for drinking. So, several researchers have been using artificial intelligence-based algorithms to predict the water quality. Here are some of the popular models that are currently being employed to determine the water quality. But as can be seen from the literature review table, there is a trade-off between the number of parameters and accuracy. So, more the number of parameters will lead to requirement of more sensors and thus leading to higher cost. So, keeping the drawbacks of the current methods in mind, the objective of our research work was to reduce the number of parameters that are needed to predict the water quality without compromising the accuracy. Our second objective was to develop a deep neural network model as they can reveal hidden relationships in the historical data, thus facilitating the prediction and forecasting of water quality. Here, I will talk about the outcomes and impacts of our research work. The outcome of our work is the WQNet, which is Water Quality Classification Model, and it will use only 5 parameters for prediction of water quality. The impacts of our work will be determining the top 5 parameters, namely dissolved oxygen, pH, biological oxygen demand, nitrate, and fecal coliform that are required for prediction of water quality with good prediction accuracy, thus reducing the number of sensors required to measure the water parameters and thus the cost. The data employed for the model development is collected by Indian government from different rivers across India. The dataset contains 1,744 samples that contain information about 8 water quality parameters, namely dissolved oxygen, temperature, conductivity, pH, biological oxygen demand, fecal coliform, total coliform, and nitrate. Here is a table representing few data samples of our dataset. So this is the overall workflow of our research. The first step of our workflow is data preprocessing. This processing is done before we apply any learning algorithms. So data preprocessing includes handling of missing values and detection of outliers. The missing values were treated by substituting the mean values of that location, and the outliers, which are basically extreme data points that due to their deviation affects the development of model. Here, bivariate analysis were used to remove the outliers. So, WQI was calculated by the following equation where N denotes the total number of parameters included in WQI calculation, QI denotes the quality rating scale for each parameter I, and WI denotes the unit weight of each parameter I. Feature selection is a method of selecting most important features from all the features in the dataset. So we applied two feature selection techniques, namely correlation analysis and mutual information gain. Correlation analysis gives us an estimate of how two parameters are correlated with each other. If two parameters are highly correlated, then we can ignore one of the parameters. So here, by using correlation analysis method, we eliminated total coliform parameter as it was highly correlated with fecal coliform. The second method is mutual information, which measures the interaction between the two random variables. So using this method, we could determine the top 5 parameters which affected water quality index, namely fecal coliform, BOD, DO, pH, and nitrate. The third step is data split. So here, the entire data set was divided into two sets, into test and train data with 20:80 ratio for performing various operations. And we also separated dependent features, that is WQI, and independent feature, that is the water parameters. The fourth step of our workflow is data standardization. The main idea behind data standardization is to standardize input features individually before applying any deep learning model. So standardization scales each feature to zero mean and unit variance. So coming to the main part of our project, the WQNet. The WQNet is a deep neural network model to predict the water quality using 5 parameters, and the output of WQNet is WQI and WQC. So this diagram shows the architecture of WQNet. The parameters were determined by using hyperparameter tuning technique. Here, a WQNet has two hidden layers. First hidden layer consists of 416 neurons, and the second hidden layer is made up of 496 neurons. The type of optimizer used is Adam, and the activation function is ReLU, with learning rate of 0.001%. So this figure shows the regression plot where predicted WQI samples were plotted against the actual WQI. The red line represents the actual values and blue dot represents the predicted values. And as can be seen, large number of predicted values coincide with the actual values, depicting higher prediction accuracy. This figure shows the confusion matrix. So a confusion matrix is a summary of prediction results of classification problem. The sum of the diagonal elements shows the number of data samples that were correctly predicted. As seen, out of 1,714 data samples, 1,672 samples were correctly predicted, giving prediction accuracy of 97.37%. So this is the classification report of overall data. Now, what precision tells us is of all the different things that have been classified as good, how many of them are actually good. That means a low precision will tell you that it has high false positive rate. What recall tells us is of all the actual good samples, how many of them are been actually detected. And F1 score is the harmonic average of precision and recall and can be used to determine whether the model is good or not. As can be seen in the table, our model performed well in predicting WQC. So we came up with the conclusion that WQNet predicts WQI with mean absolute error of 0.78, mean square error of 2.392, and R-square score of 99.99%, and WQC with an accuracy of 97.37% with only 5 parameters. So thus, with minimum number of required parameters, the proposed model can be used to develop cost-effective and time-efficient real-time water quality detection system. So it would detect poor quality water before it is used for consumption and alert the concerned authorities. So the future scope of our research work carried is cost-efficient, real-time monitoring system with only the required sensors. So based on the predicted WQI values, we can decide the best method for improving the quality of water sample. And then next, We can also develop an Android application that can check the WQR values from any remote area. So here are the references of our study. So thank you all for listening to our presentation. Now I open the desk for questions.
Thank you, Mr. Sumendra and all the co-authors for a nice presentation. So now we are moving to question answer session. So we are welcoming any question from our audience. Till now, we have not received any questions. But meantime, I have a small question to the presenter, Mr. Sumendra. So we have seen that that you have developed you have done a research on deep neural model for testing the both salt water and the fresh water, and you have mentioned that it will reduce drastically the cost because a number of parameters will not be required to monitor with the new modeling. So how have you done any comparison that actually how much percentage the cost is expected to reduce? And my another question is, can we do this testing just in place and get a result immediately, or we have to there is a time delay to get the result because there may be some calculation and other things to be done? Thank you.
So, Mr. Bashir, coming to the second part of the question, we can use some IoT system which will monitor the data and send the data on the server, and the server or the computer will do the computational part. And coming to the first part of the question, because of this method, we were able to reduce number of two sensors, that is conductivity and fecal total chloroform. The cost, in a sense, I don't have exact idea about the cost, but the the sensors are means costly. For some sensors I searched, they are like 1 lakh or 50,000 rupees. So the number also, in case if any sensor is not working, we can use this also model to predict the water quality.
Okay, thank you very much, Sumendra. It is well clear to me. So that's all from my side, and I can see that actually we don't have any more questions from the audiences. So we can move. So we can move to the next presentation.
Mr. Bashir, actually we have one question from
okay.
previous.
Yeah, please go ahead. I think then. Okay, I cannot locate in the chat box. Okay, can you share, and can you just yeah, can you just tell the question and you can answer because you are the presenter as well.
No, this question is for Mr. Chilukuri Maheshwar. The previous presentation, second paper.
Okay, so that since that question answer part is completed, and I'm not sure whether he is available now to give that question answer, so we can actually we can drop it for time being.
Okay.
Yeah. So so you can now request the next presenter and go for the next presentation. Yeah.
Now we have this session's fourth paper with title A Novel Approach for Underwater Object Detection to Mitigate Ocean Pollution Using Deep Intense Network by Ms. Surya T. from Anna University, University of College of Engineering.
Good morning all. Today I'm going to discuss a topic on a novel approach for underwater object detections through deep intense net for ocean conservation system. Agenda: Introduction, Literature Survey, Underwater Object Detections, Convolution, Neural Network Classifications, Validation, Conclusions, followed by references. Objective: here we proposed a model for differentiating animated and non-animated bodies, which includes garbages, debris, etc. Introduction: Underwater imaging is a robust tool for hydrographic analysis investigating aqualife possibilities. And with the improvement of image processing and computer vision technology, the utilization of methods for image processing and to enhance the underwater images become a major task in computer vision technologies. So frequently varying luminance and object that differs in appearance compared with the above water environment. So the main difference between the normal image and the underwater image is the color of the object color of the object under the water. So the model system uses the stacked CNN architecture, which has been optimized and forms a deep intense net. The input image is labeled and converted into train image with the back annotated bounding boxed features. The input samples of living and non-living things in the underwater environment has been captured. So the dataset is formed by using a Google Images with the brackish dataset. Among this, 75% of the images were used for training process, and the rest 25% for the validation process. So when the new input is forwarded to the network, it will map the features of the input image with the trained underwater images. These mapped features are combined to create a robust feature box that ensures the prediction quality. The model is being simulated on the MATLAB 2017 platform, and the results were extracted. The International Maritime Organization has been taken many steps to safeguard the ocean from the pollutions. Next is the related work. FAN has developed a system for using sonar images in which the deep learning is considered for classification model and achieved an accuracy of 95.5%. Drew has developed a model for detecting and differentiating the fish, underwater images of fish by using convolution neural network architecture and achieved an accuracy of 91.9%. Cheng has demonstrated segmentation of object in underwater images and achieved an accuracy of 79%. Zhu has presented a model, an algorithm, grab cut algorithm based underwater object segmentations and achieved an accuracy of 97%. So here we have created a data set of underwater images, and we have taken samples of fishes, tortoise, starfish, and non-living things such as garbage, waste, plastics, broken metals, wood, shipwreck, etc. So among these living and non-living things, 75% of the images were utilized for training process, and the rest 25% were utilized for the validation process. So the processing of underwater object detections, in the model, the detection and discrimination of living and non-living things is processed. For that, we consider living and non-living things of underwater images. Classifications of living and non-living things is processed, and then intra-class classification is done to verify whether it is fish or plastics. This model works as a dual stacked combinations of hybrid D3 and CNN architecture as feature metric as well as the region metric. The input undergoes three different phases of the process. First is salient object segmentation process, multi-class feature extraction and decision model, classification and evaluation with a deep intense net architectures. So first is salient object segmentation model. Here pre-processing is done where all the input images is resized into a fixed size of about 100 × 100 × 3 and converted into the RGB images are converted into grayscale images. So the original images are applied with the HSV segmentation in which the color corrections are made and install the grayscale images on the HSV images. Further, latest images are converted into binary images. The binary image under the HSV map the image used and compared with the grayscale images. So these are the results for salient segmentations. Figure 7, A represent the HSV color mapping. Second, B, it is converted into RGB to grayscale conversions. Third is binary converted images. Multi-class feature extraction. Multi-class feature extraction is required to extract the unique features present in the segmented images. The features are clubbed together to map the feature vectors. Then the extracted features are distributed with the random probabilistic model and non-mapped as one-dimensional vectors. Then these feature vectors are divided into training and testing vectors. 75% of the training is utilized for training and 25% is utilized for testing. Near hybrid K-tree algorithm is created by tuning the K nearest neighbor algorithm for decision making. Decision tree algorithm for making the stacked decision with a clear correlation between the training vectors and testing vectors. These trained vectors from the first phase of the classification gives the object present in an underwater images. Figure 3 shows the multi-class feature-based correlation detectors, block diagram, formation of hybrid decision tree. In general, hybrid decision tree works excellent in dealing with unordered attributes. While dealing with the unordered attributes, few multivariant trees use oblique test. Conventional univariant trees or linear associated trees. This makes the implicit and explicit process to group the numerical area into a pair of subintervals, and it converts the order to unordered attributes. Case features are evolved for describing the detected features of an image into a nonlinear space by applying the nonlinear diffusion filters. Case features also is implemented here to enhance the noise reduction effect. So here X input and X target acts as feature vectors that is formed by case feature extractions, and the corner matrix feature extraction using Harris method, actually which represent the correlation metric which is evaluated by equation 3. Classification with a deep inference net, the hybrid D3 algorithm is described, in which the training vector and the testing vector correlations are formulated. The deep correlation neural network is designed and stacked to form deep inference net, in which the input size is 100 cross 100 cross 3. The filtered stride layer, which is the filter channel, run throughout the image with a range of 10 cross 1. The stacked convolution layers are formulated by ReLU layer, softmax layer, and finally the output will be shown in the output layer. Some of the features are randomly selected by deep learning structures that may produce false results, providing the classification into neural conditions. If the quality of the images used for classification is more than the performance of the convolution neural network is improved. Figure 4 shows the classifications of underwater objects with using deep inference net architectures. The structure of deep inference net is shown in figure 5. So the probabilistic comparison enables the structure to correlate with the high matching metrics to classify the category as well as living and non-living things with its name. So these are the results for color mapping of the image under test. Here we have taken samples of plastic cans inside underwater environment. So salient object detection mapping, the result was shown in figure 7. A, which represent HSV color mapping, B represent a grayscale conversion from the RGB. Next is binary converted image. So multi-class feature extraction process results was shown in figure 8. And the figure 8, A represent the binarized images, B masked color corrected images with case features, C is the test image with corner metric detections, and D is the salient object detection. So some of the fusion results, evaluations results is shown in figure 9. So K nearest neighbor accuracy, which gives 47%, and hybrid tree accuracy achieves 99%, and decision tree accuracy achieves 99.9%. So the graph, figure 10 shows the graph of deep inference net classifications. That is our proposed method, which shows the maximum accuracy of 99%. So the validation and accuracy is formulated by using formula 4, equation 4, and the performance is calculated based on this equation 4. So some of the tables, one shows the comparison of proposed deep inference net with existing works on underwater object detections. So proposed method with deep CNN and hybrid decision tree, which gives a maximum accuracy compared to the existing methods. So some of the challenges in this work is collecting the data set is a major challenge in the in this work. So the underwater images of the CNN needs more number of data sets so that the accuracy will be achieved maximum. So that so the major challenge here is the data set creations. So the next is the conclusion. Ocean conservation is an impact area of research in which the underwater imaging has become an attractive tool for learning lifestyles of underwater living and non-living things. The present study is focused on evaluating the robust architecture to predict living and non-living things present in the underwater regions. So many techniques and algorithms are evaluated to determine the underwater object segmentation, color corrections, and feature mappings. So the present system creates a novel architecture in which the machine learning benefits are utilized with the deep learning architecture that helps to create a robust model. So the system works in two categories, in which the feature-based analysis is done using hybrid K3 algorithm, and the region-based analysis is done using deep inference net. So the maximum achieved accuracy is 99% by using the Google dataset and the Brackish dataset from the Google website. Further, the proposed model need to be improved by using more dynamic underwater images with the different scenarios and light intensities. Next is a reference. Thank you.
Thank you, Ms. Surya T. If there are any questions from the audience, please put the questions in a question answer box.
We are not seeing any questions from our audience, but I have a question to Ms. Surya. Is she present to answer? Our backup team, can you confirm that she is available to any member from the team is available to answer the attend the question answer session?
Sir, good morning, sir.
Okay, thank you very much. Nice to see you. Okay, so thank you very much for the nice presentation, and we have enjoyed it. So I have a small question. I can see that in the presentation that you have done the underwater object detection. Actually, how much depth you have tried for this detection, or how much depth this research study has been conducted?
Sir, actually, we have tested with the these images in the fish tank only, sir. It depth almost 7 to 10 meters, sir.
Okay, that is very nice. 7 to 10 meters. Okay, there's another question came in my mind that actually you discussed a lot of things, that how you can differentiate between the plastic and the normal living objects. So yes, definitely the plastic one of the major threats to our pollution. So do you predict any other items or any other polluting items your system can detect other than the plastics?
Sir, actually, we have segregated 3 items from the living things, as well as 3 from the non-living things. For living things, we have taken fishes, crab, and another one is tortoise. Well, likewise, if we see the non-living things, we have segregated plastic cans and broken metals from the ship, or broken metals. And the next one is plastics, metals, and likewise 3 things we have segregated, sir. For here I have submitted the paper with the plastic results. So we have another results also, sir. For
Okay, thank you very much. Thank you for a nice study, because this plastic is a major challenge to the maritime and the nations for no plastic pollution. So I hope your research will help others to find a solution, sustainable solution to prevent plastic pollution. So still we can see there are no question raised from our audience. So in that case, we are moving to our next presentation. So we'll be now presenting the presentation from Mr. Avijit Mohiti from Indian Maritime University, and his paper title is Sustainable Management of MARPOL 7378 NX2 Noxious Liquid Substance Wastage generated from chemical tankers at Indian ports. Thank you, and enjoy the presentation.
Hello everyone, my name is Captain Abhijit and I'm going to present the paper on Sustainable Management of MARPOL 7378 Annex 2 Noxious Liquid Substance Waste Generated from Chemical Tanker at Indian ports. Noxious liquid substances, in layman language we can say hazardous chemicals carried on ship from port A to port B or country A to country B. India is a party to MARPOL Convention 73/78 and MARPOL Annex 2 regulations for control of pollution by noxious liquid substances in bulk. When I say bulk means on ship inside the tank. Now, many times we carry also these kind of noxious liquid substances in containers also. But MARPOL Annex 2 deals with only when you carried in bulk. Noxious liquid substances means any substances indicated in the pollution category, column 17 of chapter 17 and 18 of International Bulk Chemical Code. So International Bulk Chemical Code is the code required to construct the all chemical tankers. So there are three types of chemical tanker: type 1, type 2 and type 3. As per MARPOL, they have divided all these noxious liquid substances into 4 categories. Category X, noxious liquid substances which if we discharge into sea from tank cleaning or deballasting operations, they are deemed to present a major hazard to either marine resources or human health, and therefore justify the prohibition of the discharge into the marine environment. So category X is a hazardous chemical and it is prohibited. We cannot discharge into the sea. Category Y, noxious liquid substances. They deem to present a hazard to either marine resources or human health and can cause harm to amenities or other legitimate use of the sea, and therefore justify a limitation on quality and quantity of the discharge into the marine environment. Category Z, noxious liquid substances deemed to present a minor hazard to either marine resources or human health, and therefore justify less stringent restrictions on the quality and quantity of the discharge into the marine environment. And the fourth category is other substances. Substances that have been evaluated and found to fall outside category X, Y, Z because they are considered to present no harm to marine resources, human health, amenities. So MARPOL Annex 2, when we say category X, we cannot discharge into the sea, then how we do the tank cleaning? See, when you have carried category X cargo, you need to discharge. After discharging, there will be some residues remaining in the tank. So when you do the tank cleaning at sea, you will pump out these residues along with the water. But category X residues we cannot pump out. So there is a mandatory pre-wash. So mandatory pre-wash means after completion of discharging, vessel has to carry out small tank cleaning at berth and simultaneously pump out all the effluent, all the water, all the cargo residue generated in that small tank cleaning to shore-based reception facility. So that is called mandatory pre-wash. So as per MARPOL category X, mandatory pre-wash we have to do. Category Y, solidifying cargoes. Category X, also category Y also high viscous cargoes. So when I say solidifying cargo, it means palm oil, coconut oil. Category Y, high viscous cargo means soybean oil, sunflower oil. So MARPOL Annex 2, Chapter 5 gives the operational discharge of residues of NLS. So for category X, has to be unloaded as per the PNA manual, Procedure and Arrangement Manual for all chemical tankers. It is there on board. And then you have to pre-wash as per this. The resulting residue shall be discharged to a reception facility until the concentration of the substance in the effluent to such facility as indicated by analysis of sample of the effluent taken by surveyor is at below or 0.1% by weight. That is from manifold sample. Okay, and then you can stop the pre-wash. You can go at sea and you can do the commercial tank cleaning. For category Y, high viscous cargoes. High viscous cargoes means the temperature at which viscosity is 50 MPa. Above that, if you discharge, then your cargo will not consider as a high viscous cargo. But below that temperature, if you discharge, then your cargo will be considered as a high viscous cargoes. For example, soybean oil, sunflower oil. Whereas solidifying cargoes means you need to discharge the cargo 10 degree above its melting point, then it will be considered as a not solidifying cargoes. Okay, so then you don't have to do the pre-wash, but if you are solidifying cargoes, then you have to do the mandatory pre-wash. So if you look at maximum NLS imported in India are from pollution category Y: sulfuric acid, phosphoric acid, sunflower oil, soybean oil, sodium hydroxide solution, etc. So I have made a table. I have got the list from the Director General of Foreign Trade website. These are the chemicals we import in India from 2017 to 2018 and 2018 to 2019. So by using IBC code, I have categorized them into the category X, Y, Z, and then I found the most of the time category X cargoes also we are carrying but lesser quantity. Category Y on large number of quantities, and we can see the rising trend. We are every year we are increasing the import quantity for these noxious liquid substances in India. So following operations normally carried out after discharge of NLS from the chemical tanker, which required mandatory pre-wash. So first thing, we do the pre-wash operation of ship's cargo tank. Then when we do the pre-wash, the port state control officer, harbor master or environmental officer of the port need to visit and witness the pre-wash operation conducted on chemical tanker at port or terminal. Then we need to transfer this waste from ship to port. From port, we need to transfer this waste to the suitable facility, port reception facility, where we can store NLS waste in proper chemical NLS resistance tanks in safe atmosphere. When I say safe atmosphere, it means inert condition or padded condition. Inert means there are certain noxious liquid substances. If they come in contact with air, there will be hazardous reaction. So for that purpose, we need to have a safe atmosphere. And then finally, disposal of NLS waste as per the CPCB on land-based waste reception facilities. Government of India, Director General of Shipping, has made a portal, Swachh Sagar portal, to help Indian ports to create an efficient, effective and transparent port reception services delivery for all kinds of garbage and waste generated on board. Okay, so this information and inventory are to be filled up irrespective of whether ship intends to use a port reception facility or not. If the ship is are at anchorage, such details are to be filled up weekly. In case port reception facilities are required, then the same is preferred, requested 24 hours prior arrival to port. Okay, so on that basis, they will inform to the ship that whether port has a reception facility for that waste or not. And now we will come to the problem. Okay, what problem we have as of now is that ships carrying MARPOL Annex 2 substances of category X need to do pre-wash their tanks and discharge the residues at unloading port. So to handle such cargo residues, most of the Indian ports doesn't have waste reception facility. Many of them direct receiver to deal with the NLS residues, for which they don't have unified SOP, standard operating procedure, from collection of such waste on board ship to final disposal at the waste reception facility outside port or inside port all over the Indian port. Before writing the statement of problem, I have considered few things when I was doing research on major ports in India, like what are the cargo types we import, pollution category of that, whether this port has a waste reception facility or not, standard operating procedures are in place to safely transfer this NLS, are there contingency planning in place, standard operating procedure for third-party waste reception facilities, whether they are environment friendly disposal facility available or not. And then I did research from the 13 major Indian ports waste management plan and the information received from their website, and I found only one port does not have a bulk chemical handling berth or facility. That means this port we cannot do any cargo operation because they don't have facility. The remaining 12 ports we have facility where most of the time pollution category Y NLS cargoes we import, for which we do not require mandatory pre-wash. Only one port has a SOP in place for handling NLS residues, which is also required to review for many additional safety aspect and environment friendly disposal. There are no SOPs in place for contingency planning for transferring NLS waste in Indian port. There are no SOPs for third-party waste reception facilities. So how can this problem and inadequate waste handling facilities in Indian port be solved? So we need to set unified operating procedure, make a personal protective equipment matrix, review existing waste handling practices, create general safety awareness, proper disposal of NLS waste as per the CPCB, request for suggestion from various stakeholders involved in the NLS waste management for sustainable management at Indian port, study the existing various foreign ports NLS waste management procedure, and make a facility to make a complaints regarding alleged inadequacies of port reception facilities at Indian port. Thank you. If you have any questions, floor is open to you.
Thank you, Mr. Abhijit Mohoday, for your wonderful presentation. Marine pollution is one of our primary concern facing this maritime industry, as the volume of chemicals transported by sea continues to increase, and so does the threat to the human health and the marine environment. So I'll again thank you for bringing up this timely presentation and what can be done to protect our coastal waters. And I can say that the similar situation is here in Bangladesh and in number of ports. So your study will be definitely a good guidance for us to also update our ports with regard to handling of these chemicals. So we can see here still we have not received any question from our audience, but I have a question for you, Mr. Mohti. So you have proposed a set of unified procedures for all the ports in India. So will it not be a good idea to propose the procedure based on risk assessment or risk-based arrangement?
Yes, I agree with you, and it's a part of that standard operating procedure, because I have just given a suggestion. But when we actually make the set of unified procedure, there will be n numbers of parameters we have to consider. For example, I said only the PPE matrix, personal protective equipment. So when I say PPE, it is a, you can say, more than 500 pages detailed study, because there are n numbers of chemical. What we study in our school, the number of chemical is just you can count on finger. But when you transport, many chemicals which I carried on ship, I still don't remember the names also, to be honest with you. And then each chemical presents separate hazard. There are many chemicals which present 3-4 hazard at a time. So then you have to look each hazard's different manner. Now the problem is that on ship people are trained for it. But when you see this problem, the people at port, the dock laborers, or you say the terminal people, they are not having that enough knowledge about what are the hazards. So major problem is this one, that we need to train people same like on ship we train, same way we have to train the port people also, the facility where it is going to be treated. Then only the first purpose we can solve, that is the safety of the all personnel involved in the port. So all topic, all suggestion will be based on only the risk assessment, because these are the only few numbers hazards which I have generated. Maybe when I sit and start making risk assessment, there will be n numbers of, and then hazard identification is also comes as a literature review also.
Thank you very much. You are spot on, because actually those who are work on the ships, they are quite aware of MARPOL Annex 2, but the shore-based personnel, those who are working in the loading and discharging in ports, actually they are, I would say, almost like zero knowledge on the risk associated with this chemical handling. So I have one more question, that do we need to develop a shore-based treatment facilities for this final recycling of these harmful chemicals? Because at the end this will go to some in the port, they will take it as a reception, but anyway they have to actually process this and make it sustainable for our environment. So are you going to propose anything about that?
Yes, I agree, because I have done the research on foreign ports also, and I found that basically many times ports do not have that much capability to create, because these chemicals are transported maybe once a month, or some ports maybe once in 6 months. So they cannot spend so much amount of money on the only one reception facility. So as I found that many, including you take Rotterdam or many other Houston ports in the world, big ports, they also direct, okay, for this waste reception facility to do and send us the report how you have done this disposal. Basically, the idea is that Marpol has said that you don't throw in sea, but then what is the regulation we have each country that how you are going to dispose? So in India, we have a control board like a Ministry of Environment. They have a CPCB board who directs that how to do this land-based, ship-based waste or land-based waste also, how to deal with it, how you can dispose it, and then what parameters you need to consider. Otherwise, again, people will throw back into the river and it will come back to the again sea.
Thank you very much for your nice explanation, and thank you again for the presentation. Actually, we are not seeing any questions from either in the question answer box or chat. So I think we can proceed to the next presentation. So now we'll be playing the presentation on plastic pollution and beyond. Do microbes hold the key towards a sustainable solution to this global crisis? And our presenter is Dr. Prashun Goswami from National Institute of Ocean Technology. Please enjoy the presentation.
Hello, a warm welcome to one and all present over here. I am Prashun Goswami working at National Institute of Ocean Technology. Today, I am going to talk about my research, ongoing research, that is plastic pollution and beyond. Do microbes hold the key towards a sustainable solution to this global crisis? Now, if we talk about plastic pollution and its global challenges, plastic has already emerged as one of the top 5 polluters as per annual greenhouse gas emission in the world. And if you see over here, plastic has already surpassed the living biomass in total. So as a result, many living organisms, almost all living organisms, including birds and all marine life, also several terrestrial lives, including human, is facing enormous environmental pollution issue due to this plastic pollution. Nowadays, if we go to any beaches, we can see lots of plastic trashes in and around the surroundings. If we look closely to it, we can find lots of tiny plastic particles like these, which are smaller than 5 millimeters in size. These are actually microplastics. Now let us see the scenario about the plastics in world ocean. Erickson et al. In 2014 published a research article in PLOS ONE journal in which he has estimated number of floating plastic particles in the world ocean. He had shown the number of microplastics in the world ocean are almost 6 to 7-fold higher than the macroplastic or the larger plastic items. And if you see here, these plastic debris are almost made like separate continent in the world ocean. Now let us see about the current status of plastic pollution in the Indian Ocean. A very recent study from Chitra et al., which is published this year, has shown that coastal Indian regions play one of the major source of plastic pollution in the Indian Ocean sector. And again, riverine discharge in the east and west coast of India also play a big role in distributing plastic in Indian Ocean. Now, if we compare the right side panel with the left side panel, this is the estimated values from the land-based or riverine discharge. Now, if we see here, estimation in the Indian Ocean sector is very limited, very minimal studies have been carried out. And these are some of the studies which has been already reported, in which the blue circle shows about the data from beaches, whereas red triangle shows the data from sediment, and whereas green square shows the data from organisms. So from the previous studies, it is evidence that microplastic research in Indian Ocean or in the Indian seas are in very primitive stage, and a lot of work need to be done. So for this, we have taken a study that is understanding the fate of microplastic in the Indian Sea. Our goal was first to map the current plastic pollution in Indian seas, then to establish a baseline data, and then finally to identify the source and environmental risk of this plastic in our Indian environment. So accordingly, we have collected different environmental matrices like water, sediment, zooplankton, finfish, and shellfish samples. So after collecting the samples, we did wet digestion method, then we did density separation, and then we did microscopic as well as spectroscopic identification. Coming to the next slide, the first research what I'm going to share with you today is the plastics in the food web, a case study from the Port Blair Bay. We had collected several environmental matrices like seawater, sediment, zooplankton, finfish, and shellfish from the coastal environment of Port Blair Bay. Of course, Port Blair Bay is located in the coastal region of Andaman Island, South Andaman Island, which is considered as an oceanic island. So the data over here may not be comparable with the data from the east or west coast of India. What we observed was high amount of microplastic bioaccumulation was detected in zooplankton and in some of the commercially important carnivorous fish, like up to 67 particles per fish. Further, we found organisms' dimension like length and weight and feeding habit can significantly influence the microplastic ingestion. And finally, what we observed was improper waste management, fishing and shipping activities could be the possible source of microplastic in this region. We were to identify the microplastic pollution hotspot in and around Indian seas. For this, we have taken a baseline study in Andaman Sea and Arabian Sea on board Sagar Sampada. We had collected continental shelf sediment from the both region, and what we observed was microplastic levels were highest in Arabian Sea than the Andaman Sea. It was significantly higher in Arabian Sea, you can see over here. And then as per the shape is concerned, fiber constituted the most common shape of microplastic in both the region, whereas in terms of polymer, acrylic, polyethylene and nylon were the most common polymer types. And what we also observed was upwelling coupled with enhanced primary productivity may facilitate microplastic sinking in this region. So from the previous slide, what we understood is microplastic or plastic is ubiquitous in and around Indian Ocean, even specifically telling in the coastal areas of India. So once plastic reaches to the coastal areas or coastal waters, it starts to interact with the microbes, phytoplankton, zooplanktons, or different kinds of biota. Also, on this course, it used to absorb persistent organic pollutants or even trace metals and act as a pollutant soup. So once ingested, these plastics can get transferred through the food chain and get bioaccumulated in the organisms in the higher trophic level. And once it entered the fish, it it poses risk to the human health. So this is why understanding the plastic pollution and its effect is very, very important. Now let us see what happens immediately once plastic reaches to the seawater. In seawater, many microbes including bacteria, fungi, even phytoplankton starts attaching with these microplastic surface and starts making a microbiofilm. These biofilms are known as plastisphere, and these plastispheres are housed of millions or billions of microbes, and in these microbes, some of the microbes are the specialists, or they hold the key to utilize the carbon of plastic as their food source or energy source. So in our work, we consider this kind of microbes as the potential plastic-eating microbes. So to evaluate the role of microbes in plastic degradation or biodegradation process, we designed an experiment in which we collected plastic from the coastal environment of Andaman, and we isolated the bacterial community from these plastisphere, from which we purified those cultures and screened with a preliminary screening process. And finally, we identified 4 potential microbes, which has more than 20% of plastic degradation potentials. And then we mix these microbes in growth culture media along with LDP sheets. And we have taken several steps like scanning electron microscopy, then FTR analysis, TVDSC analysis, NMR, and AFM to understand the entire microbial degradation process. So our same analysis clearly showed that the attachment of microbes in these LDP sheets, and also after 120 days of observation, we can see the appearance of folds and cracks. Similarly, in the AFM analysis also, we observed increase in the surface to energy or surface roughness. This was confirmed. So this is clearly shows that our bacterial consortium was attached with the microbes and they played vital role in the degradation process. Further, we carried out thermal degradation analysis in which we found nearly 50% reduction in LDP melting temperature after 120 days, then control. And in control, we observed 2-step degradation process over here, and whereas in treated sheet, we found 1-step degradation process. So in a nutshell, what we found was our bacterial consortia could degrade up to 47% of plastic from the control cultures. So our experiment was very efficient. Of course, a lot of work needs to be done to improve further and to develop sustainable technology or cost-effective technology to degrade plastics. So we can say that microbes definitely can be used as an alternative source of biodegradation of plastic and can give a solution on a longer term. If you want to know more about this work, you can follow our research in these 3 journals we have already published in this. And also, I would like to thank the organizers for giving this opportunity to present. And also, I would like to thank the director NIOT for providing and supporting us, and also Minister of Earth Science for their generous support towards our institute. Thank you, one and all.
Plastic pollution has become one of our most pressing environmental issues, and plastic pollution is more visible in developing nations where garbage collection systems are inefficient and non-existent. So I thank the presenter for bringing out this burning issue and the possibility to use microbes on plastic pollution as a sustainable source of global crisis. So we can now move to the question answer session. I can see still there is no question answer in the question box or in the chat. So we can wait for some time for any questions. And meantime, I have a small question for our presenter. So
please.
Yeah.
Am I visible on screen?
Not yet. I think you will be visible anytime.
Okay, I think, yeah. I started my video, but I can't see myself. That's what I asked. Yeah, anyway, you can go ahead with your
Yes,
questions.
yes, no issue. We can go with your audio. So my question to Dr. Prashun, that how you mentioned in one place, I can, as far as I can remember, that these microbes can reduce the plastic by 47% in your the specimen you have used. So is there any other way we can further increase this percentage of degradation of plastic?
Yeah. Thank you, Dr. Bashir, for your excellent questions. First of all, I would like to say that we have used one experimental setup in which we exposed these microbes with the plastics for around 120 days. So definitely there is a possibility to increase their degradation process. Like we used unpretreated plastic sheets in this. If you see in the environment, it is already, if our LDP sheet has been thrown to the environment, it's getting exposed to sunlight. So it's like exposed to UV. That itself start the degradation process. So we are working right now on pre-treated sheets, like with the LDP sheets that has been exposed to the UV to mimic the natural environment and to see whether the degradation processes increases or not. And also we are trying to optimize our culture conditions to increase the degradation efficiencies.
Okay, thank you very much. So I have one more question, since there is no question still from our audience. So in our inland waterways, there is a lot of plastic pollutions. So in your experiments, have you done it both the salt water or fresh water? If not done in the freshwater, are you planning to do for freshwater freshwater rivers or estuaries or the waterways where actually this pollution is much more larger than what we are seeing in the oceans?
Yes, definitely. Because if you see in the east coast of India, there are so many rivers which is discharging, like the Ganges Delta discharge system. So not much work has been done as far as microbial community structure on this plastics, which is coming from the freshwater environment. If I talk about the Indian Ocean sectors, maybe in the European waters and in the North American sectors, there are some reports, but as of my knowledge, there is not much work has been done in Indian Ocean sector. So definitely this is a great way to think forward, to look into the organisms which is present in the plastic in the riverine sector, because some of the organisms, they can adapt in the marine environment after reaching to the sea. So these microbes having good adaptive powers. So definitely this is a good link. So definitely we will be looking into it. As of now, we have not focused on that, since we are located in an island ecosystem where freshwater sources are very limited. So definitely on a larger scale, we have planned to work on the freshwater systems. Yeah.
Thank you, Mr. Prashan. Well understood. So with this, I think still we don't have any question answer, and question answer box. We don't have any question, and chat box also nothing. So we can call the end of this presentation. And we are actually, with this presentation, we are concluding our today all the 6 presentation and the question answer session. So I am thanking all our presenting authors and co-authors for their contribution to Ocean 22 conference. Now I am handing over the floor to our my co-chair, Mr. Sumendranath, to conclude the session. And thanks to all.
Thank you, Mr. Bashir. Uh, uh, Thank you to all the co-authors and the presenters for wonderful presentations. During these 2 hours, I learned a lot of things which I didn't know. And thank you for being cooperative throughout the presentation. Um, There is one question for Mr. Chilukuri Maheshwar, if he can able to answer this. Mr. Chilukuri Maheshwar, can you hear? I think he is not available for the quiz. So okay, so now we can end this session. Thank you for attending this conference and enjoy the conference.
Before ending, I
Yes.
just like to thank our technical team who work on the backstage, and no, they took a lot of pain to make this session very smooth and successful. Thank you very much.
Thank you.
Thank you, sir. Okay, we can leave.